Well, greetings, friends. Once again, Danielle Smith, president of the Alberta Enterprise Group. It's been a couple of weeks, but we've got such a great guest for you today. We know that we're in the middle of a transition. More and more people are adopting electric vehicles. We all carry, obviously, our devices around with us. So those are all battery powered. And we are talking about the potential for battery storage when it comes to electricity. All of that is going to need rare earth minerals and metals. And so we're going to be speaking today with somebody who's in the world of lithium to find out what Alberta's lithium potential is. There's all sorts of different components required for batteries, but it could be that if this works out, according to their plan, that Alberta will be a major player in the lithium market internationally. So joining me now to talk about this is Daniel Alessi. He's co-founder of a company called Resion, and we're going to find out a little bit more about what the lithium environment looks like, why we need it, how it works, and whether Alberta truly can be a leader in this. Daniel, thank you so much for being with me today.
Thank you for having me, Danielle. I appreciate it.
Now, I think we have to kind of walk back a bit so that people understand what the market for lithium looks like, why it's so important, why it's such a great component in batteries, and so we'll begin there, and then we'll move to talking about Alberta's opportunity on this. If anyone wants to ask a question along the way, you can always just put it in the chat. I'll be monitoring that as we go, and we'll see if we can get some of your questions put to Daniel as well. But Daniel, first of all, let's begin by telling us about lithium. When did we discover that lithium was valuable? And then we'll talk about the range of things that it's valuable for. But when did we start using it?
Well, I mean, lithium's use in batteries really comes because of its charge to mass ratio, essentially. So it holds a charge very well, and this makes it very suitable for the manufacture of batteries. So it's the lightest metal. We normally don't find it as a metal in the way that you would think about it in the environment, so as a solid. And that's in fact due to the fact that it really has an electron. It gives the atom has an electron that is freely given away. So we call it, by that we mean it's called electronegative. And for this reason, since the metal itself isn't stable at surface conditions, we find it in the lithium ion form, and that's Li+, so it's sort of a positively charged ion. So when we look in nature, we find it in solars as a salt, basically, and we also find it in hard rocks. And it's this property, again, of its ability to hold charge to its mass ratio that makes it really suitable for the manufacture of batteries.
I'm trying to go back to the early days of when I had a cell phone, and I seem to recall the early battery was nickel metal hydrate. Maybe you're going to have to correct me on that. But lithium kind of seems to me like it entered the scene a little bit later, and everyone was thinking, hooray, now I don't have to charge my battery every 2 hours. Is that kind of how it happened?
That's right. I mean, exactly what you said. So, I mean, its ability to be charged is among the highest of the rechargeable batteries. So, if the earliest technology would have been lead acid batteries that were developed in initially developed in the mid 1800s in France, and those are still available. And there's other forms of batteries as well. But the advantage here of the lithium ion battery is its ability to hold charge while also being lightweight. And if you think about transportation uses like electric vehicles, where that battery actually has to move around on the landscape, this ability to have a lot of charge per unit mass is a really valuable thing.
All right, let's sort of move on to talking about some of the opportunity for continued use of lithium, because I think I keep hearing that there's going to be some new breakthrough battery technology that will allow for us to continue to roll out electricity from wind and solar with battery backup. And I have to tell you, I mean, most of the times that I speak to somebody who's involved in the electricity world, they talk about with our current battery technology, it would be extraordinarily expensive to try to do that. So I'm wondering, is lithium ultimately going to be set aside for some other new miracle metal or mineral? Is there something else that's emerging that might actually depress our need for lithium in the future?
I think the answer to that, as a scientist and engineer, I mean, that's always possible, right? So there's if you look at the research community on both the scientific and engineering side on batteries, it's extremely active and one of the best funded in the world. My answer would be, I think in the short to midterm, that doesn't seem likely at all. There's a lot of infrastructure in place for lithium mining, for the manufacture of lithium batteries. So certainly I think these are the types of batteries that are going to carry us into the EV revolution, the electric vehicle revolution that's happening now, and that's we're looking at most cars being EV within the next certainly by 2040. After that, there's going to be there's a big bump in storage. So you were mentioning sort of ephemeral power sources coming online, things like solar and wind, which aren't like burning a fuel. It really depends on the state of the environment. And so for those, you do need storage, and it looks like lithium is going to be the mass storage for that.
Okay.
Replacements would be, if I can just comment quickly on that. Yeah, I think even here in Alberta, there's been a lot of money put in by the province for hydrogen, right? So with the idea that we can crack methane and get hydrogen from that, and then use that hydrogen in hydrogen fuel cells that could power vehicles. So that's probably going to be in parallel with lithium. I think it's a bit hard to say which one is going to be the winner, or maybe both of them would be on the market. On the battery technology side, a lot of people are working on sodium batteries. So I talked about, just to get back to the scientific piece, I talked about the electronegativity of lithium and its charge to mass ratio. That is definitely the best that's out there, because lithium is, it's number 3 on the periodic table. So it's the lightest metal element anyway. Sodium's directly below it on the periodic table, and it's an alkali metal. So it has very similar chemistry. And so there's a lot of research going into sodium batteries. Now, sodium isn't quite as good. It can't hold as much charge, so it's more difficult to develop the batteries. But the argument that these companies, there are startups working on this, particularly in the US, the argument is that if we can make a sodium battery, well, if we can improve the existing sodium batteries, sodium is abundant, right? I mean, it's present in the ocean at over 10,000 parts per million, so it's much easier to get. And so therefore, maybe the reduced cost of sourcing sodium, which is extremely abundant, overcomes the batteries that don't quite perform up to the standard of the lithium ion batteries.
All right, so that's still futuristic. So give me some idea, when you're looking out into the future and we're forecasting on lithium, what's the time horizon we're looking at? Are we looking to 2040? Are we looking to 2060? Because I'll be wanting to talk to you about some of those figures about what the opportunity is in just a minute. But give me some idea of what time horizon you're looking at.
I think it depends on the metric that you want to look at. So the earliest sort of crossover point that I would note is that it's expected that lithium supply at current production rates, which are increasing, by the way, but at current production rates, we're looking at those lines crossing where demand will be greater than supply in about the next 5 years, so 2025, 2026. You can look out maybe a decade. The predictions vary quite a bit, but you'd be looking at a demand probably 200 to 300% greater. So to give you an idea, right now, the world, we use about 500,000 metric tons of lithium per year. Maybe 400 and something last year, 500 and something, maybe 600 and something this year. If we go out a decade, we're looking at well over 1 million probably.
All right. So let me just talk a little bit more about chemistry and geology and why and where we find this. So I always get corrected when I talk about rare earth metals. People say rare earth minerals. So you have to tell me, is it more accurate to refer to lithium as a metal or a mineral?
You can I think referring to it as a metal is probably the most accurate thing. It's a metal that's found in minerals would be the way to say it.
Well, that helps. Now, what else do you need when you're putting a battery together? What are the other essential components?
It would depend on the battery you're constructing, but the big ones might be things like cobalt, manganese, phosphorus, and nickel would be the big ones that occur to me.
Okay, so I know you're not an expert in those areas, but give me some sense of the demand for lithium versus the supply and how it compares to those others. Are we going to end up with the same kind of pressure and shortages that you were talking about in cobalt, manganese, phosphate, nickel that we might be facing in lithium?
Yeah, particularly on the cobalt point. The other ones are, I don't want to call them common, but they're, there's a fairly good global supply. If we look at cobalt, it depends on what you read, but between 50 to 70% of cobalt comes from artisanal mines, basically in, 50% at least in the Congo, and then maybe 70% of it comes from Africa. And of course, the issue which has been well publicized with those is that they're not well regulated mines. Frankly, they use child labor in many cases. And so without getting into too much detail, there's been a big drive to remove rather the cobalt from the manufacture of batteries.
Is that going to be successful? Because there's sort of two ways you can approach it. You can either try to find a better, perhaps more less ethically challenged source of cobalt, or as you say, remove it. Is it which is the direction that it's likely to go? Let's first talk about removing cobalt from batteries. What would be the implications of that? I guess I always worry that if you start removing items, you're just going to affect battery life and battery power. And is that the consideration and concern?
That's exactly right. So, cobalt's used in the battery in the electrode basically to stabilize the electrode, to prevent it from oxidizing, which is just rusting, right? So if you think of the electrode in the battery oxidizing, it's not going to transfer charges efficiently. And basically there goes your batteries. So there's this interesting study out of the University of Texas at Austin where this team of researchers there built a cobalt-free lithium-ion battery that performed well over 1,000 cycles, right? So they literally charged and decharged the battery 1,000 times, and it performed at specs that were similar to those of a lithium-ion battery in which the electrode contained cobalt. So point being, I think there is some promise there.
What about the opportunity to develop cobalt in North America? Is there an opportunity? I think that there is a belt that I've heard of in Idaho, which would imply to me that maybe our geology is such that we might be able to find some of it here too. But give me some idea of whether there's a potential to mine cobalt elsewhere.
Yeah, I mean, there are some serious sources in the U.S. We can even look to Ontario. So if you look into northern Ontario, there are actually mines that used to produce cobalt alongside other metals like silver, and the idea is to get those mines back online and producing, and depending, I don't know how the resource in place compares to the demand that would be here in Canada or in the North America, but certainly there's a potential to augment some of the cobalt coming from largely Africa, using a more, I guess, ethically sourced material.
All right, now we're going to get a geology lesson so that we understand why the deposits are where they are, why they're so rich in some places and then not existent in others. So let's return for a minute to lithium and tell us currently where the largest sources are for deposits of lithium.
So there's two major sources of lithium in the world, arguably three now, but the two traditional sources. The first would be hard rock mines. So these are areas that have rocks, mostly that are most of these resources would be in rocks called pegmatites. So these are igneous rocks, so they form from magma and liquid rock deep in the earth at relatively high temperatures and pressures. And so you can think of a rock that has fairly large grain size or crystal sizes in it. And so what happens, I'll do this sort of quickly, but in a pluton, what happens is, it's a magma, it's a body, of liquid rock. And as that rock cools, the things that are most easily precipitated, that form minerals most easily, fall out of solution first. It ends up that lithium isn't one of those things. So it tends to, it's excluded from these minerals as it's forming. And so what you get, if you can imagine this rock is hardening and hardening, and there's less and less fluid. As you get to sort of the end stages where the last little bit of liquid's going to form a solid rock, it's then that the lithium will precipitate out into minerals such as spodumene, for example. And so this is really good in terms of a mining perspective, right? You can imagine that you've got a relatively small volume of magma at the end that solidifies, and you sort of, during that crystallization process where you've been excluding lithium, it's becoming more and more concentrated in that little remnant of magma. And so we look for these areas because that's areas where you can get really high lithium concentrations. That's number one.
Before you leave that, you would think that based on that, you would find it in a lot of places around the world. We've got all kinds of volcanic activity that has taken place over our Earth's history. And yet it still is a bit unclear to me why it is concentrated in certain areas and not others.
It's also, there's factors beyond just that process itself. It's also where that process happens relative to the surface of the Earth, right? So in order to have an economically feasible mine, those spodumene deposits, those pegmatites rather, have to be relatively close to the surface. And so we see that, for example, in places like Australia. So if you're looking at spodumene mines, hard rock mines, the majority of lithium comes from Australia for that reason. Are there significant sources in China, in Canada? Yes, for sure. But it's dwarfed by, at present, it's dwarfed by what's mined in Australia.
Okay, Australia, but there's other places as well.
That's right. Certainly Canada. So if you look at Nemaska's mine out in, now granted there's been some economic problems there, but there is estimated to be over 35 million tons in place in Quebec. So that's certainly a resource that's been quantified to some extent, and it's available. And, I think there was a glut of lithium. We saw lithium prices go down over the past couple of years, and they're coming back, and that played into the economic difficulties. But you look out midterm, 5-10 years, there's almost no doubt that demand is going to outstrip supply, and then resources like that I believe they'll become economic. And
it's funny to hear you say Australia and Canada, because those are not the ones that come to my mind. When I think of lithium, I think of Chile. So what's going on in Chile, and why are they such a leader in developing lithium?
Right. So we covered hard rock, and that's where I was going to go with number 2. So number 2 is the salars of South America. And so those would be places like Chile first, then Argentina, as well as Bolivia. So Bolivia has a huge resource in place that's just starting to be explored. And this gets into what are called hydrothermal deposits. So basically you have an underlying rock that contains lithium, and it's warmer. So as you go, from the surface of the earth downward, particularly in areas that are tectonically active, the temperature gets higher. And so what this does is drive fluid motion. You have a difference in temperature from near the surface down towards, where the sort of base, the rocks are, the hard rocks are, and this drives fluid flow. And so hot fluids can dissolve minerals fairly easily, like lithium. So you get a fluid that's enriched in lithium. As that goes towards the surface, then these minerals can precipitate out, for example. Or in the case of South America, we have these fluids moving to near the surface, and you would get a concentration of lithium that can be around 1,500 ppm, but it varies quite a bit. And so it's these fluids that, 1,500 ppm is, in terms of a resource, is excellent. I mean, it's, well over 10 to 20 times the concentration we have here in Alberta. So what you do is you just pump that brine up. You need to concentrate it more, so you spread it out in a surface pond, a man-made pond, let it evaporate down. You might remove 90 to 95% of the water, and then you've got a lithium concentrate that you can play with and make your battery-grade salts from.
Now, let's talk about some of the environmental aspects of both of the two types of traditional lithium mining or harvesting, extracting that you've talked about, because I think that's going to increasingly be an issue as we go forward in this new environment where investment companies are looking at environmental, social, and governance. And I wonder if we've got a lower concentration. I wonder if that's going to play in our favor, that what we're going to be talking about, the opportunity in Alberta, might be a bit more environmentally friendly. But first, let's talk about mining in Quebec. Do we have some issues with any environmental concerns that you would raise there that make it a little bit that we'd have to mitigate?
Just the normal ones. The mining practices in Canada generally are, they're among the best in the world. And I would say that whether you're doing hydrocarbon extraction or whether you're working in a hard rock uranium mine in Saskatchewan or doing a lithium mine in Quebec or a cobalt mine in Ontario, they're all, there's always, but the point is any surface perturbation is going to cause environmental issues. So first off, you're probably going to be digging a hole in the ground. You're exposing rocks to a different chemistry at the surface. So this leads to the generation of acid mine drainage. So that's, common even with lithium mines. A lot of the energy that actually goes into producing lithium from hard rocks goes into first off, the physical crushing of the rock. That takes quite a bit of energy. And then the extraction of the lithium. So there's various chemicals, including acids, that are used in that. And then all the normal stuff you'd expect with any industrial site. So you're going to be burning hydrocarbons to run machinery and, trucks and that sort of thing. It's just a matter, I think, on a site like that of having a good environmental plan. The upside, of course, of a hard rock mine, because the lithium is so concentrated in these pegmatites, is, the economics look pretty good normally. So that's something we can talk about when we compare it to brines, I guess. But again, I would see a project like that being pretty promising.
Well, and I agree, and I think we've got the best environmental practices in the world across all of our industries. I find it interesting when we get into debates with environmental groups that they seem to maybe downplay the fact that there are environmental concerns with even these greener technologies. That the batteries, to create them, you still need to do the mining, you still need to use hydrocarbons for that. We won't really get to zero emissions electric vehicles until we've managed to get to zero or net zero emissions across the whole supply chain. So I just wanted to make that point clear. So let's then move to some of the environmental issues that we've got with the other type of extraction that you just described in Chile. Are there different environmental issues that have to be dealt with there?
Yes. So we talked about this. Glad we did the geology first. So in the solids, as I said, there's this fluid, this brine that's relatively close to the surface. It's not at surface, but it's relatively close to the surface in these mountainous regions. And so you do need to drill down just a ways and pump that brine up. Keeping in mind, these high areas are very dry and arid regions, and they do have villages and towns around them that depend on the local groundwater. So if you want to produce a metric ton of lithium carbonate equivalent out of a solar, you're looking at pumping out about 2 million evaporating about 2 million liters of water. So you're basically, the water footprint is about 2,000, to speak in cubes, which is a little easier. It's about 2,000 cubes of water in terms of the water intensity for a metric ton of lithium coming out of that source. And that's not an immense amount of water if you start thinking about it. But I mean, it's a lot, but the problem is the region's already dry. And so when you remove that brine, you bring it to the surface, you evaporate 95% of the water. It's permanently removed from the water cycle. And what this has done is basically caused significant declines in groundwater that has been there for hundreds of years, and that these people that live in the area are depending on. The other thing quickly is the surface perturbance is gigantic versus the opportunity here in Alberta. So again, you've got these giant evaporation, man-made evaporation problems where you're spreading out this fluid as thinly as you can to maximize the already kind of ridiculously slow evaporation rate. And it just has a huge footprint. If they dry out, dust is generated, you breathe that in, there's all these sorts of problems. So
is there a way you can quantify gigantic? I guess part of what I've observed is that we seem to get a lot of flack in Alberta for the size of our tailing ponds associated with some of the mining operations for oil sands. And it was so interesting to me. You never really hear about tailing ponds in any other type of mining operation, and certainly not in the context of lithium either. And so is there some way to describe or compare how the land impact relates to even perhaps oil sands, which we might be a bit more familiar with?
Yeah, it's a bit different. So that, you mentioned the tailings ponds, and those are right now a terminal place for waste out of the oil sands process, right? In South America, there's actually a series of ponds, and you would be reusing these ponds. So, there's sort of a sequential evaporation going on. So they're actually part of the production process. And the other thing I mentioned there, so if you think about the oil sands tailings ponds, they're engineered, right, to reduce or mitigate any leakage out of them. That's the idea. I'm not saying there's evidence for problems here and there, I would argue. But if you look at the evaporation ponds in South America are not engineered like that. So you definitely have leakage of these fluids, back into the groundwater as well. There's also a combination. The
only thing I'm thinking of is I visited Turks and Caicos years ago, and they do have salt ponds on a couple of the islands. And I gather it'd be the same kind of approach, that you are just evaporating down, and then how do you mine off the lithium? Do you just give me some idea of how that process works?
Right. So you would do the sequential evaporation. You get a fluid that's enriched in lithium, and then you start adding carbonate, dissolved carbonate solutions to it. And what carbonate does is it precipitates out some of the other ions, the positively charged ions besides lithium, that you don't want in the final product. So using that sort of just basic precipitation chemistry, you can purify the fluid to a great extent. You can actually precipitate out. So almost all precursor, the product that you would ship away from a mine is almost always going to be lithium carbonate. And then that lithium carbonate can either go to some sort of a process to further purify it as a carbonate, or often it's sent for electrolysis to produce lithium hydroxide. So those are the two major battery salts, the precursors that the battery manufacturers use to make their batteries.
I'm glad you explained that, because I know that when we get into the discussion of pricing on these, there's two different pricing, one for lithium carbonate and one for lithium hydroxide. And we will get to that in a minute. Now, as we move to talking about the opportunity in Alberta, I'm interested in knowing whether, if we perfect what happens in Alberta, would that assist Chile in being able to have less of an environmental footprint, or are they just two totally different processes?
Not necessarily, yeah. So we haven't gotten into the Alberta process, but most companies, startup companies that you see in Western Canada, that would be primarily Saskatchewan, Alberta, and British Columbia, use some sort of a direct lithium extraction process or a membrane separation technology. And so that's definitely applicable to brines in Western Canada. But what I didn't mention about the solars is that they're fairly inefficient. So your lithium recovery from those places might be 50 to 60%. And if you're dealing with a fluid that has 20 times the lithium concentration than we have here, you can make a go of that. There are two angles there potentially: applying technologies that have been developed in Alberta to actually the source brine itself in Argentina or Chile or Bolivia, or actually the waste stream itself. Sometimes the waste streams from these facilities have hundreds of ppm lithium. So it's really a case where their garbage is literally our gold, right? Though even those waste products may have 3 to 5 times as much lithium as an average brine in Alberta. And so there are companies, I know several of them that are including Resian, that's reaching down into South America to see if there are operators or miners down there that might be interested in us having, a look at their waste products or their brines.
All right. So then let's talk a little bit about what the opportunity is in Alberta, because the way you've described it is that it isn't optimal, but if you can reduce some of the environmental impacts, then that improves the performance. But tell us why it is that we have lithium in Alberta. What's gone on from a geological point of view that causes the brine to be infused with lithium?
So the first thing to say is there's ongoing research in this area, both in Saskatchewan and Alberta. So there's not a clear story that fits all of the resources that we have. But generally, the story would be similar. The idea right now, and it was published in a AGS AER report several years back now, is that it is the hydrothermal story. So you have underlying igneous rocks, essentially, in which fluids circulate. And those fluids, because they're hotter, again, picked up lithium from these source rocks. And then those brines, the brines are in higher layers of rock that are higher up, closer to the surface, and that's why we see the concentration of lithium in these particular formations.
And what would be the implication of that if that turns out to be the case? There's sort of two things that I'm thinking of. One is that we're pretty good at being able to develop technology to enhance what we've got. I think of horizontal multi-stage fracking, for instance, where we are able to create a technological mechanism to increase the amount of gas and oil we were able to get from shale. And I wonder if there'd be a similar application that we could use here. Is there any way to increase the parts per million of lithium?
Not in the brine itself. I think the research that's going on in the basic geology, both at the Alberta Geological Survey and the Saskatchewan Survey, if I understand correctly, and a lot of the team on the stratigraphic and geology side of things, is identifying again which rocks have the lithium in them and why that lithium is migrated into the places that it has. And that's, of course, useful from a resource assessment point of view, because if you can identify characteristics, if you can use things like lithium isotopes to constrain the story, that gives you a much better chance of prospecting, right? So if you look in Saskatchewan, for example, there's people buying up land without even having done a water test on it, because there's not an available well to test the brine. And I think that's promising, going forward, especially as people have bought up a lot of the water rights in Western Canada now, looking at potential new areas. We're really, given the oil and gas infrastructure available in Alberta, we're part of this big survey that's basically looking at every well in the province, so every oil and gas well that's been drilled, and its location. I mean, there's a lot of testing that has gone on. So often the better option for an operator is not to, hypothesize about why this or that might be the case. Just simply get a brine sample from a wellhead in a region and have it tested. And that gives you an idea of not only the lithium concentration, but other things in it that might make lithium extraction difficult.
Okay, so give me some idea of how much of that work has been done, because I'm doing quite a bit of work on how we can reclaim some of the non-producing wells. And so the numbers that are sticking in my mind, having just looked at this recently, is I think we've drilled something in the order of 535,000 wells, and that's all types of wells. I think even including water wells. I think we've got something in the order of 160,000 non-producing wells. But have we done this testing before along the way? Do we have a pretty good idea of where we might find lithium?
It's not traditionally in the list of things that you would test for, right? Because you're looking at lithium being present in these wells, anywhere close to zero. But the highest recorded numbers are some in Alberta anyway, are somewhere around 140 and 150 ppm. There's debate around that because of the accuracy of the measurements and all that kind of stuff. But point being, in terms of oil and gas operations, it's completely a who cares. If you're drilling a well 30 years ago, you wouldn't be thinking about lithium. So the data set is limited. There was, again, some done by the province. That's in our report available online from, I believe it was, I don't know if it was even AER back then, but whether it was ARC or AER, that report's available. I think Roy Eccles was one of the main authors on that. And to answer your question, a lot of the testing that's going on now is private companies and startup mining companies interested in lithium concentrations, as well as an effort now by the provincial government through AER to actually fund some of this testing. So there's hopefully those numbers will be coming out in an AGS or AER report at some point in the future.
So we must have some testing, though, to get an idea that we do have an opportunity here. So where we have found it, tell me where it is. Give me some sense of where the opportunity is.
Yeah, it's throughout Alberta. So I mean, big ones would be the Leduc Reef is definitely an area, as well as thinking of oil and gas operators that do hydraulic fracturing. So if we look, for example, in the Duvernay Formation, which is Devonian age, so that would run across the Alberta-BC border, but primarily in Alberta, linked to hydrocarbons. That's also another major opportunity. Montney Formation, I should have said the Duvernay Formation. The part that's accessible is in Alberta. The Montney straddles the Alberta-BC border, rather, and that formation, there are some lithium hotspots, but generally that formation has lower lithium concentrations, at least from what we've seen so far.
And you'd mentioned Saskatchewan as well. Why is there opportunity there?
For the same reasons, right? So this sort of, the geology extends across the border. And so we have primarily there, you're looking at things like the Bakken Formation, which has been well developed, and opportunities like that.
Okay, so I'm trying to figure out the approach that we take here, because I'm working on a project that would reclaim and incentivize reclamation of some of these old well sites. But in point of fact, you kind of want to make sure that there isn't anything valuable underneath there before you do the reclamation. So how are you coordinating all of that with the companies that have a mandate to remove their liabilities? How do we know that they're not going to be reclaiming something that you might find useful? Is there any coordination happening there?
I don't know the answer to that, because there's obviously a lot of potential private partners involved. I would just point back to the fact that, if reclamation is going on, and the fate of particularly old infrastructure is going to be determined, it would be great if there was some drive towards at least doing the lithium testing and the basic chemistry on those wells to determine whether they're a resource. Just because it would be a shame to have the infrastructure already in place and then, abandon that infrastructure basically irreversibly and not be able to access a resource from it. So.
Totally agree. So would lithium testing take place? I mean, can you do it at the same time? If you've got a producing well, can you also do the testing, or would you have to wait until the production's over?
Oh, yeah, for sure you can, because there's always almost all wells have a pretty significant water cut. So it's just a matter of getting a sample of that water, either, if it's a well that's already completed from right from the wellhead itself, or even if it's on production, obviously, if it's a fracked well and you're starting to get flowback and produced water, you can take it right after the oil water separator, for example, and just get an idea of how, even how lithium concentrations are evolving as a function of flowback time. So. Okay,
I'm going to put this conversation on pause, that part of it, because I may want to return to it to see if there's any policy implications for me on that, because I'm with you. I mean, if one of our big advantages is that we're able to use the existing infrastructure there's probably a few things that need to be sorted out. So I'm going to probably get a to-do list from you at the end, but I think people need to understand a little bit more about how we might even have an opportunity for lithium here. First, let me begin, because you said something quite interesting about testing the water. And lithium is the rage right now, but are there other components in the water that we should be paying attention to that might have future value?
Yeah, the big one. So I would say first off that nothing quite compares to lithium at the moment, but boron is an interesting one. So boron is used in some lithium-ion batteries, but it's also potentially able to be used in hydrogen storage. So it could actually link up to the hydrogen economy. And again, really the economics of this depend on, if you're already pumping up the brine as part of a hydrocarbon well, and you're already doing the lithium extraction, and you just got to add another box in your plant that's doing the lithium extraction, you might be able to make some of these things feasible. The other thing is rare earth elements. So there is some work also starting in the surveys on REEs, rare earth elements. The concentrations are pretty low. So I would say at this point it's difficult to see an economic case for them. But one should never forget, again, that these are, we're talking about cobalt. Well, it's the same with rare earth elements. They're often sourced from politically difficult places with maybe labor practices that we don't agree with here in Canada. And the idea of having a domestic source, not only of lithium and cobalt for the manufacture of batteries, but also rare earth elements for electronics in general is I think exciting. Even if the cost is somewhat more, right? There might be an additional production cost, but these are supposed to be renewable technologies. And, there's obviously an economic case has to be made, but hopefully there's that vision to look at these resources.
You have to forgive me because I'm not as familiar with this space as others might be. So you'd mentioned boron as one example, and you're saying doing an assessment of other rare earth elements. Are there a few others that are particular candidates that might be good opportunities for us to be looking for?
It's really the whole suite. So the rare earth elements comprise a pretty large set of metals kind of down at the bottom of the periodic table, which have unique properties. And so in general, if you look at your iPhone, for example, they would have numerous rare earth elements. They also have lithium and cobalt and all that sort of thing. But they're just generally useful in the manufacture and critical in the manufacture of electronics.
It's interesting because you say even though they might be small quantities, I gather that you probably only need small quantities when you're putting these together. But it's also a very high price if you're measuring it out on a kilogram basis.
Exactly that, yeah. So you're not needing large quantities, but they're critical and the price is quite high. So even cobalt, right, is 3 times the price of lithium.
Wow. Okay, I'm trying to figure out. This is sort of interesting to me because I'm trying to figure out whether there's a ability to have the companies working together at the same time while you're continuing to develop the hydrocarbons. If you can also pull out the brine, I'm sort of trying to figure out how your process works. So let's go through how your process would work under normal circumstances, and then we can see if there's a cooperation possibility, because that also then creates some interesting opportunities for additional revenue streams for ESG investing. Because if you're going to be pulling out and extracting rare earth elements that can be used for battery power, you should be able to get some credit for that from an ESG point of view. But we also know that hydrocarbon producers, they pay land access payments. If you're able to sort of piggyback on that, that might assist with sharing the cost on land access payments. It might assist with bringing some companies into compliance with their municipal property taxes if there's some sharing going on there. So as you can see, my head's churning a little bit about how we might be able to have these two industries working together. But first, let's talk about, you find a site. It's got the ideal amounts of parts per million in it. You'll have to tell us what that is. And then tell us how you extract it. So walk us through the process.
Okay, so brine identification in Alberta. From a process side of things, and I would say this is whether you're using what are called direct lithium extraction processes or membrane processes or other, there's actually organic solvent processes. I'll get into those in a bit. But first thing you're obviously looking for is lithium concentration. And so in Alberta, again, your range of economic brines is going to be somewhere between 50, maybe a bit less ppm, parts per million, up to about 150 ppm, which would be the dream, and those are quite rare. Typically, the ones that we've been testing in Alberta have, they lie between about 40 and 80 ppm is extremely common. That's not the only story, though. So I guess if anyone here is an operator, it's not about going out and trying to find the highest concentration of lithium, because it also depends, the extraction efficiency and ultimately the economic feasibility also depends on three other major factors. So first is the temperature of the brine. That's normally not a problem. We've seen it a problem in 1 or 2 places, but on a lot of these are chemical extraction processes. So a brine that's relatively hot, and by that I mean maybe 40, 50, 60, even 70 degrees, or even a bit more, is optimal. And what that does is it speeds up the kinetics or the reaction speed of the the extraction process. Because if you think about it, you've got a brine that's got a large volume, you've got to move it through this process quickly to get enough lithium out to make it economic. Number two, and the operators will be super familiar with this, hydrogen sulfide. So it's an oxidant, it destroys infrastructure. It's going to destroy the infrastructure in the lithium extraction plant too, including the actual reagents that are doing the lithium extraction. And the third one is...
So you don't want, I guess that, do we look at that as being sour gas? Is that what we're talking about there with hydrogen sulfide? So anything that has a high sour gas content would probably not be a very good candidate for lithium extraction?
Potentially not. So there's a balancing game, right? Because, I mean, if the lithium concentration was very high and the H2S was not ridiculously high, maybe you could make a case for pre-treating to remove the H2S. So that's all. It's a complicated conversation.
Again, we're talking about such small amounts when we're talking about lithium. You talked about 50 to or 40 to 150 parts per million. When you say a hydrogen sulfide content that is not particularly high, what are we talking about there?
Yeah, it would have to be, I mean, often you have single digit percentages and sometimes even more H2S. We'd be looking at knocking it down at least into the hundreds of ppm, which might still be on the high side, but yeah, tens to hundreds of ppm is kind of what most of these processes would require.
Well, I guess that helps to narrow it down a little bit. There'd be certain wells that you'd be able to exclude, I guess, on the basis of the presence of hydrogen sulfide, yeah?
Yeah, for sure. So if you have a well that has, 30 ppm lithium and H2S is 10%, I mean, you could talk to somebody, maybe you could come up with, if you never know about the operator. Maybe they say, hey, H2S is no big deal for us. We already have an on-site process. This is like a piece of cake. Well, okay, then maybe that 30 ppm, if you can deliver that 30 ppm to the lithium plant with the H2S completely stripped away, and the other thing is organics, I'll throw that in there as well. So, obviously you're producing waters that have been in contact with hydrocarbons. So that's a little less critical, but you want to knock down the hydrocarbons essentially so that the materials in the lithium extraction process don't get coated in with the organics, and then you can't get the lithium into the material that's recovering the lithium. But yeah, if you have a H2S free brine that has 30 ppm lithium, that might be a lot better than an 80 ppm lithium brine that's got 5% hydrogen sulfide. Okay. So there's a little bit of a game to be played there.
Now, I did interrupt you. You were going through three. So we've got parts per million is what you're looking at in the first place, and the higher the better on that. You mentioned temperature of the brine, hydrogen sulfide, and you just mentioned hydrocarbons as well. Is that your third element, or is there something else we're missing?
Yeah, hydrocarbons are organics in general, so dissolved organic compounds. I mean, if you have free product, that's really not ideal. So, we don't want floating product on the top, but there's even going to be dissolved organic. Some of the hydrocarbons, they're relatively insoluble, but there is some that's in solution. And so, that's something we also want down in the hundreds of ppm range or less in order for these processes to work.
All right. So then tell us how you bring the brine up. What's the mechanism there?
It depends on what you want to do. So there's sort of two proposed routes in Alberta. Route A, which is kind of what Resian's been focused on, is working or pairing with an operator that's already producing water alongside hydrocarbons. So, the oil and gas companies are really water businesses as well. They're moving big quantities of water that are deep well injected and in the case of hydraulic fracturing, sometimes recycled to some extent, but the point is it's costly. And so there's an idea there that, hey, you're already producing the water. Even some treatment is going on at sort of these centralized regional water hubs. Could that water be borrowed, the lithium stripped out in a fairly small process? I mean, we're talking about a large shed or maybe a large garage on the site. Lithium product produced on site or a precursor product, the water delivered back to the operator, and then the water goes on its way. You've just stripped out 100 ppm lithium. Number two, there's some startup mining companies that are looking at actually drilling their own wells. So in other words, they'll drill their own gallery of extraction wells. It'll go into a much bigger scale plant, ones that can produce tens of thousands of tons of lithium carbonate equivalent per year to be competitive on the world market. And then, water goes through the plant, lithium stripped out, and then they have a gallery of injection wells where that water would go back in. The advantage there being, of course, that they can target the key spots in those formations and have a great resource. The downside there being that the capex on that is going to be immense, right? So you're talking about hundreds of millions of dollars. Where, I think the other approach of looking at existing infrastructure is a little scrappier. You just kind of go out and if you can put together, you talk to a big oil and gas operator or some mid-sized ones, and you can put together a portfolio of sites where you can produce, say, 1,000 tons LCE per year, that's enough to make a go of it and make a profit. And again, if some of that profit can go to offset the water costs, to me, I see that as another attractive alternative here in Alberta.
Have you got an example of where that is currently taking place?
Right now, everybody in Alberta is at the pilot stage, right? So whether that be in the laboratory pilot stage, they're developing their processes and scaling it up, or they're moving towards, I guess I wouldn't call it a demonstration plant, because a demonstration plant is probably doing several hundreds of cubes of water per day, but they're doing, I would say, a field prototype where, you might be able to run several cubic meters per day through the plant. And it's nice because, again, what you want to do is get to a stage where even if you're working at a water hub up in Fox Creek or something, you want to be able to push, it depends on lithium concentration, but your plant's probably going to be doing several thousand cubes of water per day in order to get the type of tonnage you need to make this thing economic. And so, the field prototypers where a lot of people are going, can I process 1,000 liter a cube per day? Can I process 10 cubes per day? Can I do, once you start getting up to 100 cubes per day or more, then you're looking at, or certainly when you start getting up to 500 or 1,000 cubes per day, then you're looking at a demonstration plant. And then beyond that, you have a commercial facility, right, where you're actually producing lithium at a profit.
Are there any partnerships that you know of that I can look into, or is this all proprietary information at the moment?
Sorry, I missed
Is there any demonstration projects that you're looking at? I'm interested in knowing if there's already one of these partnerships on an existing well site and they're using that well site as a pilot, or if it's more the second that you were talking about of a company drilling their own wells.
In Alberta, neither of the, there's definitely plans to move that forward. You could look out to Saskatchewan, for example. So it's not a demonstration plant, but Prairie Lithium has gone to the field scale. So they're working on a well, sort of piloting their technology. Demonstration plant scale, that would be the US. So if you look at, for example, Standard Lithium down in Arkansas, there's a couple plants down there that are at sort of operating scale and going towards commercial scale.
So let's talk about the economics of this then. Why would an energy company that is producing the water and having to recycle it the way you've described, what's the economic benefit for them of working with a company like yours to try to extract the lithium?
I would say the hard benefit, the operator first ask themselves whether they're interested in being in the lithium mining business. So whether the answer is yes or no to that might inform the type of decision they make. But the short answer is, again, the price of lithium is quite high. So I don't think we mentioned that, but lithium carbonate right now, last I checked, is around $14,000 US per ton. Lithium hydroxide, the other product's about $15,500 per ton. So despite the fact that, if you were going to go develop a lithium mine and the portfolio was the world, your dream source of lithium would not be petrobrines in Alberta. That's just a frank statement, right? But given the prices now and the fact that demand is going to triple in the next decade to 15 years and prices seem to, they're going to be volatile, but probably continue on the upward trend, at least in the midterm. If you can link on this existing infrastructure, you don't have to pay millions of dollars to get the water, and you can do the lithium extraction and get the product to market, there could be a considerable offset to the water disposal cost. Do I mean that this is going to offset all of the water disposal costs? No, that's probably not possible. But we did some preliminary numbers, and it depends, again, on all these factors of the lithium concentration, the amount of water, where we sell it on market. But you might be looking at a double-digit percentage offset on water. So I'm thinking on a per well basis, it could be in the six figures, for example.
So let me get an idea then. For it to be, so $14,000 per ton, but we are talking about parts per million. So I'm wondering, in the very best case scenario, what would the annual production be out of one of these sites? I'm just trying to get a sense of whether you're going to be able to accumulate enough parts per million to make up enough tons to make it worthwhile from a financial perspective.
Yeah, I guess I'll just quickly state the plant process. So the boxes would be brine source, that's number one, goes to the plant. The plant up front has an extraction process. So that's often called a direct lithium or a DLE, a direct lithium extraction process, which normally has a solid phase sorbent. So these tend to be manganese and titanium sphenyl oxides, but they can also be organic solvents and membranes and all those sorts of things. The next box is you've concentrated the lithium. It goes into a polishing and purification step. And then on site, you can produce a product if you want. So that could be a concentrated fluid, or it could be a precursor salt that you then go off and make battery grade products. And so to answer your question, if it's Alberta, I think first off, you don't want to be working on a single wellhead because the water supply from a single wellhead is quite intermittent. What you want to do if you're working with existing infrastructure is focus on centralized water hubs that have a reliable supply of water that might be in the high hundreds to several thousands of cubic meters per water, and has, as best you can, you'd have to work with the operator, but see if you can optimize around the lithium concentration, or at least have a way of tracking it, right? Because wells are coming online and offline all the time. And so what you want to do is make sure that if you have your lithium extraction plant on site, you can deliver reliably, even if it's a modest value, like say we can get 800 cubic meters per day to you, no problem. And the lithium concentration is going to be 40 ppm. That's the type of thing that might work if you can replicate it on several sites. So if you want to get to 1,000 tons LCE, which is that's lithium carbonate equivalent, which is often cited as a scale that would be economic. Depends on which plants you're working at, but you might need 4 to 10 of them or something like that. And then you collect all that product. You make the precursor site very close to the water hub, maybe up in Fox Creek if it's a Duvernay, and focus that all to one transportation site, and then send it off basically to market or for further purification.
How many opportunities so if that's the optimal way of doing it, how many sites in Alberta could be potential sources for you to have an economic site that you would set up?
There's a lot of regional water hubs, so I think there's a good opportunity. The resource in place in Alberta has been estimated at, depends on who you ask, but over 6 million to over 10 million tons LCE. So that's quite a bit of lithium. Even if we look out in 5 years from now, where world demand will be 1 million tons per year, that's basically 10 years of the world's demand. But it really, again, there's a good question about what those 6 to 10 million tons LCE numbers mean, and this relates back to your question. Not all these brines, at least right now, not all these brines are great. And the ones we've looked at brines from a lot of operators, not only here in Alberta, but Saskatchewan, from BC, and actually down in the US. And if you pare down the ones that work out against those metrics that I said, lithium concentration, organics, and H2S are the big ones. In terms of ones you'd want to work on tomorrow with the existing technology, you're looking at, I would say, maybe 10 to 20% of them. But that's okay. I think that, you target those up front, and it gets to a point that I'm kind of getting off on another point, but the technology is a major limitation, which is why we founded our company. So we're very much about pairing technologies to specific brines. So I think you want to prove out the technology on the optimal brines with the operators that you're talking to. And then what you can do is play around with your demonstration plant, your pilot plant, or even at the benchtop scale in the lab, and say, okay, that's 10% of their brines, but they've got this other brine over here that's got higher H2S. Can we find a trick to play with that? So it's this innovation, I think, that's going to make a greater fraction of that 6 to 10 million tons LCE accessible as we go forward.
Now I'm trying to do the math based on what we've been talking about before. If it's valued somewhere in the order of $15,000 per ton, and we have the potential for 6 million to 10 million tons, what are we talking about for total estimated value of this resource?
So I guess if you believe the 10 million LCE, then you multiply that by 15, so $15 billion basically.
Okay, well then let's talk about sort of the next steps that you're looking at for how to develop this out, because I think people need to understand just how much lithium is used in the different things that we use, like an iPhone or a car battery, or even if we're talking about a lithium centered battery for a storage of electricity. Give me some idea of how much lithium is needed for each of those things.
Okay, so I guess an easy midpoint to start with, and one that everybody's interested in these days, is electric vehicles. So if you look at a Tesla, it's got about 10 kilograms of lithium in it. So that the lithium, that battery, might be worth 150 or $200, basically, at least at market prices. Keeping in mind that lithium is not actually the major cost of a lot of these batteries, right? So it's actually those rare earth elements, not rare earth elements, but also, rather the rarer elements. That's different than rare earth elements. But things like cobalt, for example, are a lot more expensive. Nickel as well.
How expensive is cobalt by comparison? Is it also priced in a per ton volume, just so that we can try to compare weight to weight?
Yeah. So right now it's over 50,000 US per ton.
50,000 per ton. Okay, got it. So it's three to four times higher than lithium.
That's right. Yeah. So a car, a Tesla might have 10 kilograms. We started getting into major storage. So as I mentioned, that's going to be the next, I think, big wave of demand. There you're looking at least hundreds of kilograms per battery and beyond. Smaller electronics, it's really a nominal amount. So you're in the grams range, essentially.
And when you say, so what are you anticipating will happen on price? I mean, if you're saying that we're about to cross 5 years from now, where the demand outstrips the supply, that always means that there's going to be a price implication to that. So what's the expectation there?
I think it's exactly that. I mean, everything that I've read on market analysis is most people say it's very hard to predict the price, and that's based on past volatility, even in recent years in the lithium market. So the uncertainty comes from the fact, first off, that there are a lot of hard rock mines coming online. We look at Bolivia, which has a massive, two salars in particular, but those are being actively prospected and development has begun, as I understand. And then we have our opportunity as well. So I don't mean to interject uncertainty into the conversation, but it's hard to predict. The demand is fairly reasonable to predict. There's good trends on that, and certainly 250 to 300% increase in the next decade is reasonable. But how price ties to that, I guess, depends on the timing of how these mines come online. But in any case, I think, the 5-year point, there's going to be a pinch point there. It's pretty hard to get away around that.
So we've talked about how the resource is not as rich as elsewhere, but if you can piggyback on the existing infrastructure, that might balance it out a little bit. So tell us a bit about the value of having the infrastructure already in place.
Well, the infrastructure is, it's even if you're looking at a modest site like I talked about, where you're doing 1,000 cubes of water per day, that you might produce 100, 150 tons of lithium per year. And again, you'd need 6, 7, 8 of those sites to make your 1,000 tons that I was talking about or more. I mean, that infrastructure is 8 figures probably. You're looking at the wells connected to that site, and then the site itself, the water treatment facility. That infrastructure would be, millions and millions of dollars to replicate. So that's a savings essentially to the lithium extraction process. And you're right. The low lithium concentration is the problem. You're really doing, I've characterized it before as a needle in a haystack. So 50 parts per million is that's a lot of water to move through a process. But given that you don't have the infrastructure costs, and given perhaps, I think in the future, and I've talked to some small startup companies and actually some battery manufacturers about the green lithium case. I think that's an interesting point. Can we charge a premium for lithium that's sourced from Alberta because it's low CO2 footprint compared to the hard rock mines and the salars we talked about? Their answer right now is maybe not so much, because the person that's buying a Tesla already believes that and rightly so, that they're contributing to a low carbon future. But that argument might work in the future, right? And if I think that argument, green lithium coupled with domestic lithium, if you're looking at a modest markup, that might be a good selling point for this the product we have.
So if we talk about the universe of the development of lithium being worth $15 billion, I'm trying to put that into context, because obviously nothing really compares with the value of hydrocarbons. And so everything seems small by comparison, but $15 billion of economic value still seems like a lot of money.
Yeah, and we should keep in mind that that's just the resource itself, right? So that's just the mining aspect and the sale of the lithium salt on the market. The real question, I think, on a lot of people's minds right now is why send this off? Why send the precursor product off? So the precursor product might only get $6,000, $7,000, $9,000 per ton, right? Why not have the facilities here in Alberta to turn that into battery grade lithium hydroxide or lithium carbonate, or better yet, why not just make the batteries ourselves? I mean, that's, particularly if you look at, assuming cobalt's still going to be incorporated, and these other metals, manganese, nickel, and those sorts of things. I mean, all those are available here in Canada. There's a thought that, and there's some action actually in Ontario about having a battery plant here in Canada that's a serious battery plant that could actually compete on a world scale.
Would we do that in Alberta? We tend to have this approach. It's very strange, where we extract the resources in Alberta and then we ship it off to somewhere else, whether it's the United States or whether it's Ontario, to be processed. But would this be a domestic opportunity for value added? Like domestic meaning to Alberta?
I am excited about that. I mean, we're even thinking of, if Resian couples with a partner like we were talking about, and we're producing a precursor product. For example, a precursor product might just be a dirtier form of lithium carbonate. the battery standard's about 99.5% pure, and that's what the spec on the market of 14,000 per ton is based on. Even that, we're looking externally. Even within Canada, there's places that would do the purification to turn it into lithium hydroxide or whatever. And if I think the answer is yes. I mean, if you're producing, whether it's a combination of companies coupled with oil and gas companies or pure lithium miners, having an ability to send all those products to a centralized facility in Calgary or Edmonton or whatever it happens to be, and produce at least the battery grade salts there to ship out to, a battery plant overseas or down to Tesla or whoever it happens to be. I don't know the feasibility of that, but I've talked to a lot of people who think it's an exciting thing to explore, I guess is what I'd say.
So Elon Musk has his gigafactory in Nevada. So would that be something that we would look at trying to displace the current supply that he has? Or would it be, let's try to create a partner facility in Alberta?
I guess it could be either way. It might even, maybe that preliminary, you have to send this product out for processing initially to get it to battery grade, so that if this becomes feasible, it starts happening and we're producing lithium products at a commercial scale in Alberta, I think initially a lot of them are going to get sent out for purification, and then maybe they get sold to Tesla or in a traditional way to ceramics manufacturers. But once you have a certain volume, I would think, having a plant here locally where you could, locally meaning Alberta, where you could do this sort of processing would be a pretty good idea. Kind of like, it's like upgrading of hydrocarbon products in Edmonton, right? It just seems like a good idea.
It does. And obviously Elon Musk caused a lot of turmoil in the Bitcoin markets when he talked about them not being green enough. So selling this as a greener form of one of his major components, there might actually be a sales case to be made there.
Yeah, and Tesla's very exciting. They have a good story, but I guess we should keep in mind also that the traditional auto manufacturers out in Ontario and Michigan and elsewhere in the world, the foreign companies as well, are really going full bore on electric vehicles now. So it's not like this is going to be the only market in the coming 5 to 10 years.
Okay.
We have that opportunity to sell wherever we wanted, I think.
So let's then talk about that. So if we did that value added opportunity, give me some sense of what the upside is on this industry from a value perspective. Are you able to map that out?
The primary benefit that I would see is, again, this traditional, as you were basically alluding to, this traditional role of us as being a provider of resources, a resource provider, and then those get shipped off for upgrading elsewhere. So if we can bring the production of lithium grade salts, so lithium carbonate at 99.5%, lithium hydroxides at 56.5% is battery grade, because there's a water molecule in there, long story short. But if we can produce those via electrolysis or have chemical purification plants here at a scale where, we're talking about this 10 million tons LCE in Alberta. Now, there's a question about how quickly that's going to be produced and, how many hundreds of tons we might be looking at per year. But if we can do that internally and save some money internally on doing it as a province, then certainly the margins for profit are going to be bigger if we can sell directly to the battery manufacturer in China or wherever it might be, rather than sending it off for an extra intermediary step. So.
Well, but also, I suppose if you actually create that type of facility here, you have to wonder what else might decide to co-locate when it comes to a business park or something. I don't know. I can't really think of anything offhand. Can you maybe fill in some gaps there? Is there anything else that if you created a hub for this type of battery grade lithium, what else might we be able to attract?
I would go back to the battery plant. So I think you're exactly right. And that gets to I kind of forgot about this in our conversation, but the $15 billion is just that's the starting point, right? That could support a much bigger industry.
All right. Yeah.
Like manufacturing.
So, okay, now I need to understand some of the policy challenges that you're facing. Are there any policy challenges? And in some ways, when you think about how difficult it would be to get a traditional mining operation up and running with all the approvals and public consultation and the new environmental process, in some ways this is a bit of a shortcut because all of that already exists. So there's the regulatory streamlining advantage that we would potentially have. I'm just wondering if there are any government barriers that are in the way. What is the barrier? Is there an information barrier? Is it that some of the operators don't know what they don't know about the potential? What do you need to have happen in order to take this from demonstration to reality?
I think the environment here in Alberta has been pretty good. So I'll start with the government. you look at programs, I guess, like Alberta Innovates Clean Resources, and there's other sources, they have been putting money behind Alberta startup lithium companies, whether they're miners or technology providers like Resian. And that's been quite helpful because, as I said, the technology is one of the things that's lagging a bit here. Not that it's not appropriate, but there's a lot of tuning of the technology to match it up to the brine. My point being is that we need that kind of support in order to be able to try to get this out at a commercial scale and to production, and making sure that the process itself, the internal guts, the reagents, the things that are doing extraction can survive the needed number of cycles for the process to be economic. Because to be frank, the major expense here is not only the infrastructure, but actually the chemicals in the process itself, which are sorbents, for example, solid phase sorbents. So I don't see that as it would always be nicer if these programs were, the more that's available, the better. We can move things more quickly. But I think there has been some vision there. There's definitely been some vision from the federal government in terms of clean energy programs at that scale. And a lot of these companies are benefiting from that. The operators, they, at least in our experience, now keeping in mind this is just my experience with Resian, and we've approached several companies and had conversations with a lot of them. The lithium miners, these are the people that they're interested in lithium, and they have this vision that Alberta can be a major lithium supplier. So the majority of the testing that we have been doing is with startup lithium companies in Western Canada that have a resource, and they send us their brine, and they want to know how to go forward as quickly as possible to develop a feasible technology to start selling lithium products. Major oil and gas companies, we've talked to some of them, and we've been talking to people who talk to some of them. I think it's just it's what you said, making a case that laying out the economics, laying out the cost to them, laying out the potential benefit, and getting somebody to bite on doing a field scale prototype, something that might be able to process 1, 10, 20, 100 cubes per day. And I think once somebody, this is essentially what Resian's goal is to work with somebody like that, whether it be an oil and gas company or an operator, and other companies as well in Western Canada. But to start producing, at least at that scale, a product, whether it's kilograms per day, and say, hey, all we need to do is scale this up, and it's going to be economic. So is there uncertainty there? Sure. But, at least all of our preliminary economic analyses would suggest it's at least got pretty good promise.
Wow. It sounds kind of amazing, actually. When you think about, oh, sorry, I'm getting some feedback in my ear. Are you hearing that?
I'm not, it's fine on my side.
Let me just keep talking and see if it goes. Okay, it ended up going. I was getting a little bit of feedback. But when you think about the potential for this, that if you could get essentially every company that's in operation and pulling up water to just say, hey, why don't we test it as a what if, just to see if there's something there, then lithium could be one potential product of the future. And then who knows what else might develop out of it. And then you could develop a database so that you would then have access to this information so that all your entrepreneurs would know the best place to go to. That would almost be the optimal if we could get to that point.
I agree with you. Yeah. I mean, there's always a question about, having worked on oil and gas water databases, there's always a question about what's proprietary and what's not, and what might give a particular operator or a miner an advantage in the market. But I think that approach, it's sharing as much as possible. There's certainly been a sharing tradition in Alberta in terms of the oil and gas industry, which is great. So hopefully that can also extend into this market. And again, I think the provincial surveys that are going on, those are going to be public reports that are indicative and give really the geology and the science behind the locations of lithium. And they'll include, I'm also at the University of Alberta as a faculty member. So we're doing some of this work, the chemical analysis of these brines for the government. And that data is going to be made public, which is great, because then, anybody can come along and read this on freely on the provincial website and get a sense of where the resources are.
And so is the University of Alberta emerging as a bit of a hub and expertise in this area, or how is the University of Calgary doing?
I think both for sure, right? So there's been work on lithium extraction up here at U of A and down at the U of C. By the way, also now starting out in University of Regina on rare earth elements. So one of my colleagues out there. So it's well funded, yeah. And certainly, one advantage of the university setting, it can be a little bit slow. It's having worn both hats, the academic environment is definitely different than the commercial environment, the private environment. But one advantage of the university is that there's time to think deeply about some of these problems that, you can try to move as fast as you want to get out in the field and do something, but if your base technology isn't working, you're just going to spend a lot of money on a pilot or a demonstration that doesn't work. And so there is this, and Ressian, as an academic, and Salman, my co-founder of Ressian, we're both come from academic backgrounds. I think there's a little bit of that culture that we'll never quite extract from ourselves, and we're very interested in understanding the fundamental reasons why a particular process might work or not work for a brine.
Well, it's fascinating. Now, I know you and I mapped out a lot of things we wanted to talk about before we came on today, and I want to make sure I didn't miss anything. Is there any other aspects of this new industry that we should know about?
I did write a short list here, and I think you covered pretty much everything. I think you'd mentioned battery recycling as maybe one point that we didn't touch on. But
well, I guess that's the only other thing, because I'm very conscious of the fact that when we start talking about being greener and having a lower environmental footprint, like, keep in mind, I came to environmental issues from the landowner perspective with the work that I was doing with the Western Stockgrowers Association. So I'm very concerned about landscapes and biodiversity, about water quality, about air quality. And it seems whenever we talk about the hydrocarbon industry that we act as if there aren't any other environmental impacts happening elsewhere. So we've talked about a few of them in lithium and some of the other rare earth elements we're going after. But one of the things that has been raised with me is we don't seem to have a very good strategy around recycling batteries at end of life. And I don't know if I understand all the reasons for that, because we've had a great conversation. You've reminded me a lot of the chemistry courses that I took in high school that I had forgotten. So thank you for that refresher. But it seems like we've developed a lot of chemical processes to pull out and change what it is that we need when we're talking about pulling it from the earth. But that's why I don't understand why it's so difficult once you've created something and put it all together. Why is it so difficult to extract those elements back to their base form? As I understand it, we just don't have very good processes for recycling batteries at end of life. And if that's changing too, maybe you should fill in the gap for me.
Sure. It's happening increasingly even if you look at lithium ion batteries. So recycling now is over 50% globally, which is good. It's just, there's a lot of metals in batteries, right? We talked about some of them. So it's, you're looking at normally in a plant that might be doing just battery recycling. Those are going to come into one big bin: lithium, cobalt, manganese, phosphorus, maybe arsenic, nickel for sure. And you would grind those batteries up basically first. So you'd shred them all. They would go and then they would go into chemical extraction processes where you basically have to separate out those metals into fairly pure streams so that you can then sell off the metal. So it's expensive. And up until recently, it wasn't, break even was considered quite good in this business. You look at Li-Cycle now, which is a Canadian company that's building a almost $200 million plant down in Rochester, New York. I mean, they're looking at taking in massive quantities of batteries at the scale that would make it economic. And I think they're also bolstered by the fact that the prices of things are going up, right? All these battery grade metals, lithium, cobalt in particular, but even the price of nickel is high. If you can, it does depend on the continuing price of these metals, but there's a profit to be made there. And then there's also an argument that maybe this is a type of activity that should be supplemented to some effect to encourage recycling. So it's on the radar. There's a lot of, and I truly believe that there's a lot, people are opening their eyes to a renewable and carbon neutral future. And I don't know how much it is the case now, but I think it's increasingly the case that people are willing to pay a premium in many cases if it means doing the right thing.
Certainly. Well, and you also just sort of give me another idea of what we might have for our lithium hub. If we're going to do value added, then you probably could also bring recycling into that. And I wonder, would that make some sense, using harvested lithium from batteries in conjunction with what you would be pulling from the ground? Or are they two totally separate? Could they not be very easily amalgamated? Would they be two separate feedstocks?
The extraction process would be separate, but then, the products could end up in the same bin that goes to market. So I don't see why not. And you're right, because especially if it wasn't just the producing the battery grade lithium, but you had a battery plant there, Then, of course, by recycling the batteries, you have a side stream of cobalt and nickel and these things that
Right.
obviously going to offset all the needs for the manufacturing, but those could be just slotted right back into the battery manufacturing process on site.
That's amazing. Well, thank you so much for the work that you're doing. If people want to continue following, you've given us a few different sources where people can go. So you mentioned that there's different reports coming out, I believe, is it the Alberta Energy Regulator that's producing the reports on lithium, or is it another agency?
Those
Alberta
are
Innovates?
Yeah, they're in the incipient phases. So there's an older report on lithium resources, and that's available through AER.
Yeah.
But in terms of the new work, it's actively being funded. So as I said, we're doing some of the brine analysis work here at the University of Alberta, and other people are doing the hard rock stuff. So looking at the rocks and where the lithium is sourced and completing that story about, how did lithium get from the source rocks into the brines? And so I don't know, the timeline on those honestly is probably a year or two at least. Those aren't out there.
Well, still, that's not that far away. And what about following the work of your company? What are you publicly traded, or are you private?
We're private at this point. And yeah, we do have a website though. So it's just Recion Technologies, all lowercase, and .com.
And let me just spell that out too, because it's RECION.com, correct?
Recion Technologies.
Technologies.
Yeah.
RecionTechnologies.com.
Yes. Yeah,
I've got it now. All right. Well, Daniel, thank you so much for the conversation today. I sure appreciate it.
No, thank you for your time. It was very enjoyable.
That was excellent. So Daniel Alessi, he is a co-founder, as I'd mentioned, of the lithium company, RecionTechnologies.com. If you want to check them out, RECION Technologies.com. And that's probably got a few of you thinking what the potential opportunities are for how these companies can work together, number one, but also whether we can create a hub so we can do some value added, which seems to be where the real opportunities are. All right, my friends, we're out of time for today. As I mentioned before, we were going to do East Meets West on Canada Day, which would have been very appropriate. Unfortunately, one of our guests that day had to bail out for a personal reason, but we are stepping up to do that again. I think that's the one that we're doing next week. Not only East Meets West to find out where the opportunity lies with our Ontario friends in finding common cause, but one of the things we will be talking about is the labeling of plastics as toxic and the implications that has for not only our petrochemical industry here, but also some of our manufacturers in Ontario. So I'm looking forward to that one. But as for now, we're out of time. And if you missed the full episode of this, as you know, we will be circulating it on audio podcast. You can find this wherever you get your podcasts. It's also going to continue to be available here on YouTube. So thanks for tuning in. We'll talk to you again. I'm Danielle Smith, president of the Alberta Enterprise Group.